Good afternoon. Welcome back to our S block elements. So we'll see very fast the sodium hydroxide preparation and use and the sodium hydrogen carbonate or baking soda. Then we'll go to the S2 elements. So sodium hydroxide is also one of the important compound in this thing. It is prepared from electrolysis of electrolysis electrolysis of brine solution, that is sodium chloride solution is electrolyzed using this cell electrolyte cell is the anode and cathode is carbon anode and cathode is mercury cathode is used and sodium chloride solution, and in the at cathode you will get a sodium mercury amalgam on addition of water you will get sodium hydroxide, and here you will get the at anode you will get chlorine gas. So that is this thing. Sodium hydroxide uses are the wide variety of uses are there. First, everybody knows about the soap manufacturing, even artificial silk in water treatment plant, that is for the regeneration of the DM plants, and then petrochemical refining, bauxite purification with aluminum ore, bauxite purification, then the textile industries, then you will even in the cotton fabrics, in even the preparation of the pure fat oils, laboratory, like that, so many things. Another important compound is people call this sodium bicarbonate, or people we are also carbonate sodium hydrogen carbonate also. It is very simple this thing. On heating on addition of the sodium carbonate on addition of with water and CO2 you will get sodium bicarbonate, or people will say sodium hydrogen carbonate also. So these are the two in the S block. Now important issue is the in the body, human body, sodium and potassium are more biologically compared to are required compared to iron or copper. Everybody says iron deficiency, copper deficiency, hemoglobin, this and that. But actual this thing is sodium and potassium are requirement is more for the human body, and so excess is also dangerous. Okay, now coming back to the S2 block. The elements are, first element is beryllium, then comes to magnesium, then comes to calcium, strontium, barium, and radium. These are S2. I miss 1s2 to S2. Last I will write that is 3s2. It can be written like this also. This can be written as helium 2s2. This can be written as, because helium is 1s2, it can be written as helium 2s2. This can be written as neon 3s2. Neon is 10, because here it is a 4 number, 4 plus 8 12, neon is 10 plus 2. Calcium is 12 plus 8, 20. 20 plus 18, 38. Strontium 38, then 38 plus 18, 56. 56 plus 32, 88. So finally it will be helium 2s2, neon 3s2, then argon 4s2, krypton 5s2, then xenon 6s2, then radon 7s2. This is radioactive again. So that is the nomenclature. So that means in the outermost orbital there is a 2 electrons, that is also in the s block. So this is the normal your electronic configuration. And if you see the atomic ionic radii compared to the alkali metals, these radii are ionic radii, ionic and atomic radii is less compared to alkali metals. These are called alkaline earth metals. Alkali metals. Right. Now, if you see the ionization potential, ionization enthalpy is also less, because compared to the S1 it is more, but here it is less also, because it is easy to remove the first electron from the 2s2 this thing. Ionization enthalpy is 899, 737, 590, 547, 503, and so on and so forth. So that is the ionization enthalpy. Then ionization enthalpy also increases, is going down along with the size. That means beryllium is more, beryllium plus as plus 2, then magnesium plus 2 is next, then comes to calcium plus 2, strontium plus 2, so on. That is the ionization enthalpies. Then hydration enthalpies of alkaline metals is larger than those of alkali metals here. Then if you see the physical properties, first they are all metals. Silver in color, unless white in color, silvery white or silver color in color. Luster, relatively soft. In case of this, you see the calcium, sodium, you are cutting with a knife and all these things. Right. Here, in the earth, if you see magnesium and calcium, these two are most important and widely available. They are, though beryllium is not that much occurrence. That means it is in the earth crust, it is like a 2 ppm and all. That is beryllium. Strontium, barium, if you see, they are some 384 ppm and 390 ppm like that. And anyway, radium is 10 to the power of minus 6 or something much lower. Whereas magnesium and calcium, they are highly required and available also and the earth crust. That is some 2.76% is magnesium and 4.6% is calcium. This is this thing, and that is the availability. And flame test, not all like alkali metals, not all that test you cannot carry out with the flames. whereas calcium, strontium, and barium is they can be detected by the flame photometers and atomic absorption center. And magnesium, everybody knows that magnesium can be made as a very useful in the cracking, that is magnesium wire or this thing. Now coming to the chemical properties, what normally we discuss with the chemical properties is, one is with the air, reaction with the air, another is with the halogen, then hydrogen, then acids, reaction with the acids. If you see the reaction with the air, it will form oxides. The reaction with the halogen, it will form the halogen because it is a divalent. So Mx2, X is a halogen, so chlorine, bromine, iodine, anything, fluorine, bromine, and all. So that is Mx2 will form. Whereas in hydride, it will form as the metal hydride, that is the beryllium hydride, magnesium hydride, like this hydrides will form. And air means it will form the oxides. The oxides is the beryllium oxide, like this. With nitride, so it is forming magnesium nitrate, magnesium oxide, calcium oxide. Oxides will form, nitrates also. And on reaction, they will form with the hydrochloric acid. If is reaction, it will form the chloride, corresponding chloride, and hydrogen gas will be liberated. So they react vigorously with readily with the acids like hydrochloric acid or sulfuric acid and all. So tomorrow we will see the other chemical properties.